If this is our round table, then our Martian is sitting in chair 1 and an Earthling is sitting in chair 15. To the left of the Martian is chair 2. So as we proceed to the left, we're going to be going counterclockwise around the table. According to the rules, we can't have an Earthling in chair 2. So that means chair 2 can be occupied by either another Martian or a person from Venus. Let's map this out chair by chair. If we have a Martian in chair 2, then to his left can be either another Martian or a person from Venus. If chair 2 is occupied by someone from Venus, chair 3 can have someone from Venus or someone from Earth. If chair 3 is occupied by a Martian, then chair 4 can also have a Martian or someone from Venus. If chair 3 is occupied by someone from Venus, we could have another person from Venus or an Earthling. And if chair 3 is occupied by an Earthling, it can be followed by another person from Earth or restarting with a Martian. If we trace these paths, we can see that we can go from any number of Martians until we run out, and then we continue with some number of people from Venus. And then after Venus, we have to be followed by an Earthling. After an Earthling, we restart again with someone from Mars. Writing this out horizontally, we'll start with some number of Martians, followed by a certain number of people from Venus, one or more, continuing with some number of Earthlings, and then starting over again with Martians, Venusians, and Earthlings. And then we end with an Earthling in chair 15. One easy way to do this is to put all 5 of our Martians in a row, followed by all 5 of our people from Venus, and then all 5 of our Earthlings. I'd like to call this a group of MVEs. Here we have one such group, and there's one way to arrange them. But we can also have 2 groups of M's followed by V's followed by E's. We need to divide our 5 Martians into these 2 groups so that we have at least one Martian starting each group. We can do that with stars and bars. We want to place a divider between our 5 Martians in such a way that divides our Martians into our 2 groups. So for example, this divider represents the situation where we have one Martian beginning the first sequence and 4 Martians beginning the second sequence. Independently, we can divide up our 5 people from Venus into our 2 groups any way we like, as long as we have at least one person from Venus following each of these groups of Martians. For example, I can place a divider here, which corresponds to 2 people from Venus being in this first group and 3 more in the second group. Our Earthlings can also be divided up independently. For example, a divider over here means we put 4 Earthlings in this first group, and then our last Earthling is here in chair 15. Now we'll continue with 3 groups of M's, V's, and E's. We need to divide up these 5 Martians into 3 groups so that every group has at least one Martian. I'm choosing 2 out of 4 spaces to put my dividers. That's 4 choose 2. It's the same count for people from Venus and our Earthlings, so that's going to be 4 choose 2 cubed, or 216 ways. I forgot to count for k equals 2. That's 4 choose 1 ways of putting a divider between our 4 Martians, and then we cube it for our people from Venus and Earthlings. That's 64 ways. Let's go on to k equals 4. That's 4 groups. Each group has to have at least one Martian, a person from Venus, and an Earthling. That's 4 choose 3 ways of putting in a divider, and it's the same thing for V and E, or 64 ways again. Finally, we have 5 groups. That's putting a Martian, a Venusian, and an Earthling, one of each, into a group. That's just one way. Adding these up, we get 346 ways of arranging our committee members from 3 different planets. When we return to the problem statement, we notice that they want us to format the number like this. Wondering where the 5 factorial cubed comes from, we can take a look at one of our sequences. If we can tell our Martians apart, we can number them M1, M2, M3, M4, M5. And we can see that we can arrange them in 5 factorial ways. That's true for our Venusians and our Earthlings as well. So from our 3 planets, that's the cube of 5 factorial. So 346 is our answer. If you'd like me to solve any other contest problems, please leave them in the comments.